Okay, so let's go here. What you have is the graph of the velocity of a particle moving along the x-axis. Okay? Okay, the graph of the velocity of the particle moving on the x-axis. The particle starts at x equals 2 when t is 0. So when t is 0, the position is x equals 2. So what is this? This is the graph of the velocity, right? So let's explicitly say, instead of y, that that's v. And if this is t, then that's v of t. All right?
But doesn't it look like
So this is the velocity. Okay. This is the position. Those are two different things completely. Okay. So what is the velocity? How fast is this thing going at t equals 0? 0. At t equals 2, how fast is it going? 2. Okay. At t equals 7, how fast is it going? 2, but in the opposite direction. All right, so we know how to read this now. So at t equals 2, the velocity is positive 2. At t equals 7, the velocity is negative 2. In both cases, it's going at the same speed, but in different directions. This is negative, this is below the x-axis, so v is negative, it's going to the left. Above the x-axis, it's going to the right. Okay, so this is v and t, and the question we're asked here is, find where the particle is at the end of the trip. All right? So if we have v and we want location, what are we going to do? What is it? We need to find displacement. Okay? So where the particle is at the end, we need, if this goes from 0 to 10, what we need is s of 10. That's what it's asking us. All right, so what is s of 10? S of 10 is s of 0, okay, where it was originally, plus the total amount it was displaced from 0 to 10.
That's okay. A plus, correct? Not a t.
That's a plus. Okay, so s of 0 is 2. Originally, it was at x equals 2. And then how much of a displacement was there? Well, now what we have to do is we need to find the area of this, right? So what are we going to do? The top here, that's a positive area, right? So how could we find that? That's a trapezoid, right? Okay, what's the height of the trapezoid? 2. And then how much is base 1? 3. And how much is base 2? 6. So plus 1/2. There you go. 1/2 times the height times 3 plus 6. Okay, now this area in here is negative, right? And that's a triangle. The base is 4 and the height is 2. So minus half times base times height. Okay. So how much is that? That's 2 plus 9 minus 4, 7. So that's s of 10. All right. Total displacement was 8 units. No, 5 units. Okay. So that's A. B, it wants the total distance traveled. So B, total distance, is the integral from 0 to 10, absolute value v of t dt.
And we plug that into the calculator.
Well, no, because it's still, the integral of v of t is still the integral, right? Now when you have this, basically if you want the absolute, if you want the total distance, right? It's the same as the velocity and the displacement, but now positive, right? So if you want total distance, so look, how much it traveled here was 9 units. Here it traveled 4 units, but in the negative direction. So now if I just say 9 plus 4, right? That's 13.
So why did we do the other ones as calculator?
Because we don't know how to integrate a function, like the absolute value of a function. But you can find the integral by area. All right? So before you weren't given the graph.
I see.
Okay. All right, here's another one. A pump is connected to a generator operates at a varying rate, depending on how much power is being drawn from the generator to operate other machinery. The rate, gallons per minute, so that's important. I always underline that. That's the rate, gallons per minute, at which the pump operates is recorded at 10-minute intervals for 1 hour, as shown in the table below. Now what I want is how many gallons are pumped during that hour. So I'm given rate, gallons per minute. So again, I always write this. I'm given rate in gallons per minute. I need amount and in gallons. So again, the question is, what should I do to what I have given in order to end up with gallons? What should I multiply with? By minutes, by a time unit, by a time increment, right? That means I need to do rate times time, right? Rate dt. Okay, so let's take a look here. I have gallons per minute. I have minutes. Units are consistent. That's amazing. Now, look, when you're given this, right? If you're going to do this, it's basically the integral, right? It's the integral rate times dt. Well, if you have a function, then you find the integral. But if you don't have a function, okay, what does integral mean? Integral means area. And if you have a list, do we know we use the trapezoidal rule? I've told you here, use trapezoidal rule, but what if I hadn't told you? This is why I was saying all that preliminary stuff. All right? What I need is this times dt. That's the integral. Okay, what else does integral mean? Area. Oh my God, how do I find area? Oh my God, trapezoidal rule. Okay? So, so look, if this is time and rate, right? Time is on the horizontal axis, so my trapezoids are going to be like this, right? That means this is the height. So time is the height. And let's see here. Height is going by tens each time. All right. So the area underneath here is going to be 1/2 times the height times base 1 plus, remember how do we do these? 2 of each of them. Okay, so 2 times 65. Can I do it in one shot? Like 2 times 65 plus 58 plus 55, 59, 60, and then just 1 of 63. So in the end, 3575. So in this hour, 3,575 gallons of, what is it, pumping? We don't know. Do we?
Yeah,
Gallons are pumped.
Liquid.
Yeah, it doesn't say. Yeah. Are there tissues anywhere? Oh, here. So you see how, like, here it's being pumped at 58, and then it's being pumped faster and then slower, and here it really slows down, and then it really speeds up here. But in all of that, this is how many gallons are pumped. All right. So net change. Question? Okay.
approved.